Congratulations on making it to phase 6 of your Cisco Cert success path. After we laid a strong foundation with stage 0 and then filled in the gaps with stage 1, and since everything routes and switches, we earned our CCNA in routing and switching in stage 2, and we followed that up later in stage 5 with a CCNP in routing and switching. We learned about cybersecurity and network programmability. Now finally in stage 6, it's what do we want to do? What are we super curious about, and what do we want to work with? This is where I say we choose our own adventure. If you like design, then I would do design. If you like wireless, then I would do wireless. You've got a strong foundation. Now it's time to become an expert in whatever interests you. And when I say that, I'm primarily thinking about Cisco because this is your Cisco Cert Success Path course, but it's not limited to Cisco. We'll talk about some other options. If you do want to stay in the Cisco world, here are the different tracks from which you can select. You could do design and get your DA, your Cisco Certified Design Associate Design Certification, all the way through your CCDE, the Cisco Certified Design Expert. In fact, you could even take that to the highest level above the IEs and the DEs. You could become an architect based on design skills. Things are moving to the cloud, so that might be a good track to go down. One of my personal passions is collaboration, and I won't read through the whole list, but you see there's quite a plethora of certification tracks from which you can select when it comes to Cisco, but there's a lot of non-Cisco certifications that are also very much in demand out there. And this is by no means a comprehensive listing, but these are some of the big certs that are out there, and I picked these because I'm familiar with these. I know people that work in these areas. Project Management Professional, that's very much in demand by a lot of larger organizations who are going to be managing really large projects. And we talked about things moving to the cloud. And Amazon, with their AWS certifications, they've got several different certifications you can select from. You can kind of build out your Amazon cert list, sort of like you built out your Cisco cert list. If you want to get into a vendor-neutral security certification, CISSP is super popular. And not even listed here, but you could go into CompTIA Security Plus, and they have several different security certifications. Virtualization is a big skill to have these days, so you might want to take a look at getting VMware certified. But if you're staying in the Cisco track, at some point you need to make that decision. Are you going to get your CCIE certification or not? So let's think for a moment about to CCIE or not to CCIE. You see, I don't really think the CCIE is for everyone, and it might surprise you to hear me say that, but I've seen so many people put forth a lot of time and effort and money, and they never earn their CCIE. I want you to know going in that you will finish. There will be no giving up. If you go in and commit to this, you are going to finish, and I want you to go in knowing that there's going to be a huge sacrifice, and you're willing to make that sacrifice. I don't want you to come to the end of your life and have this as how people remember you. I don't want it to be on your gravestone that you were a CCIE. That's not the purpose of your life. There's a big sacrifice that you're going to make, and you need to understand that going in. Personally, it took me about 1,600 hours to prepare for my most recent CCIE certification. That's a lot of time. From October of 2011 until March of 2012, I studied every single day for I took Christmas off, but literally I studied every single day other than Christmas for months. That put a tremendous impact on my family. It took a tremendous impact on my health. And even after all that study, I still say that lab was the absolute hardest thing I've ever done in my professional career. I don't regret doing it, but I went in with the passion. I wanted it. I was hungry to get it. I didn't choose to get my CCA because I thought it would be a good career move. I thought, I just really, really want it. Before you decide to make the commitment, you've got to really, really want it. And think about whether or not you're going to be able to dedicate the time and energy necessary. And think about how quickly you learn information. I'm not talking about intelligence. Some people simply process information slower than others. Some people are internal thinkers, so they can figure out problems in their head. Some people are external thinkers. They like to talk it out with somebody to figure out a problem. In the lab, it benefits you to be an internal thinker because the proctor's not going to give you much information and you cannot chat with your neighbor. Also, you've got to have good typing skills. I remember after passing my first CCA lab, I made the comment that I would have failed if I had not taken a typing class because there was so much typing involved. If you're a slow typist or if you're an external thinker, those are things that could potentially hold you back. Now, you can certainly overcome that. You can take a typing class and you can go through lots and lots of practice labs and you can get good at your internal thinking, but it could potentially take a long time to to pass your CCNA lab. For my first CCNA, it took me 3 attempts. For my second one, it took 2 attempts. And that's about the average. It's around 3 attempts on average to pass the lab. So be aware of that going in and decide in advance if it's for you or not, and if you really are committed to going for it. Now, out of all of those different adventures that I listed, and many more that I did not list, one that I'm personally passionate about is collaboration. So I thought in this video, I would just give you a taste test of the collaboration track, and maybe you can see if it resonates with you or not. You may have no interest in it, but you may think, hey, that's really cool stuff. I want to learn more about that. So let's talk about collaboration, which is really sending voice, video, and data over the same network. You see, the case used to be where companies would have separate voice and video and data networks. I remember when I used to work at a local university, I could go into a wiring closet and literally there would be 3 different groupings of fiber. One for the video system on campus, one for the telephony system on campus, and one for the data system on campus. But voice over IP started to change that. With voice over IP, instead of having PBXs at different sites, those are privately owned telephone systems. The university I worked at, we had a PBX system at the main campus, and then we had smaller PBX systems at remote campuses, and we paid monthly for a line, like a tie line, to connect from the main campus to the remote campuses. Well, what you can do instead of paying for that tie line, if you've already got an existing data network, you can simply connect your PBXs with appropriate interfaces into routers, and the routers can packetize all the voice signaling and the voice media. It can send that as IP packets over an existing IP WAN. And the voice packets themselves, they use a protocol called RTP, the Real-Time Transport Protocol. In addition to that, there are different signaling protocols that can be used, like SIP, to get the session set up. But this is a way that we can immediately start to save money by getting rid of a WAN circuit that we pay for on a monthly basis. And that begs the question, how do I take the spoken voice, an analog waveform, and convert that into ones and zeros? How do we digitize voice? Well, let's think about that. Voice is obviously a continually varying analog waveform. We want to represent it as a series of ones and zeros. So what we can do is take snapshots. We can measure the amplitude at different times. Here you see the dots representing those samples that we take. If I take enough samples, I can represent the amplitude and the polarity of those samples digitally with ones and zeros. And then we can just connect the dots on the other end to regenerate an approximate analog waveform. Now here I'm taking probably more samples than I need. This is called oversampling. If I don't take enough samples, then I get what's called an aliased signal. You see here, I'm not taking enough samples to accurately represent what the waveform looked like. And if you connect the dots here, yeah, it doesn't look much like the original waveform, does it? So how many samples should we take? Well, there was a man back in the 1920s named Harry Nyquist, and he came up with the Nyquist theorem. And the Nyquist theorem says that at a minimum, the number of samples that we should take is twice the highest frequency that we're sampling. Now, the human ear can hear all the way up to about 20,000 hertz at the high end. Well, if you have a healthy ear, if you've listened to a lot of rock music in your teenage years like I did, maybe you don't hear quite to 20,000 hertz. But we don't have to have some sort of high-fidelity Bose surround sound in order to send voice across the network, because over 90% of the frequencies making up what we need to understand human speech are under 4,000 hertz. So that's what we go for. We try to sample 4,000 hertz, 4,000 cycles per second. And according to Mr. Nyquist, if our highest frequency is 4,000 hertz that we're trying to reproduce, we need to sample double that. We need to take 8,000 samples per second. Great. Now the next question is, how do we take this sample? Well, there's an infinite variation of amplitudes of an analog waveform, so we have to round off a little bit. Here I've got a scale of 1, 2, and 3 just as a simple example, and you see my samples that I've taken. And you'll notice that none of those line up perfectly with the numbers 1, 2, or 3, so we have to round off to the nearest number. That rounding off is represented by the delta symbols and the brackets that you see on screen. This is error. This is when we're being less than completely accurate. And this can lead to noise. It's called quantization noise, which sounds sort of like hiss in the background of a conversation. So how do we reduce quantization noise? We could take a bunch more samples to be more accurate, but a way to preserve bandwidth and still have better quality audio is to use not a scale like this, not a linear scale, but to use a logarithmic scale. With the logarithmic scale, we're being more accurate at the lower volumes. And this gives us a couple of benefits. By being more accurate at lower volumes, we're being more accurate for most of the samples because most of the samples occur at the lower volumes. Also, the higher volumes tend to be so loud that they tend to mask the background noise anyway. So we want to be more accurate and have more potential values to which we could round off at the lower volumes, the lower amplitudes. So we're using this scale, which is broken into segments, and the little dashes within a segment are called steps, and we have to say whether we're positive or negative. So doing that, we can represent a sample with 8 bits. One to say, what's the polarity? Is it above the line or below the line? Is it positive or negative? Then we say in which segment is the sample. We can do that with 3 bits. And then we can say what is the step value within that segment. We can do that with 4 bits using this logarithmic scale. That means that a single voice sample can be taken with 8 bits. And according to Mr. Nyquist, we should take 8,000 of those samples per second. 8 times 8,000, that means, not including overhead, we need 64,000 bits per second, 64 kilobits per second, in other words, to do an uncompressed sampling of voice. And there's a codec, a coder-decoder that we commonly use on Cisco IP phones that requires, for that reason, 64 kilobits per second of bandwidth for the payload only, not including overhead. And that's the G.711 codec. To say bandwidth, though, there are some different codecs out there that can still give us good quality. They're a little bit lossy, but personally, I'm probably not going to notice the difference much, if at all. G.729 takes up only 8 kilobits per second of bandwidth for the payload. That does pretty good for voice. It's not so good for music on hold. It was designed for Latin-based speech patterns, not music. But it does a good job of compressing and saving bandwidth while giving us good voice quality. A newer codec that we're seeing on our Cisco IP phones these days is ILBC. It gives us better quality than we get with a G.729, but it does take up a bit more bandwidth, but typically that's a good trade-off because bandwidth is not as scarce as it once was. So that's an overview of how we can digitize human voice, but what does a complete Cisco unified communication solution look like? Well, there are different servers that we can use, and I've listed several of those for you on screen. We won't take the time because this is not a full-blown unified communications course. We'll not take the time to describe what each one of these players does. But let's talk about some of the big ones. What about Cisco Unified Communications Manager, CUCM? I think of that as the PBX replacement because it's in that device, it's in that server where we're going to set up things like our dial plans. Phones register with the CUCM. One CUCM can talk to another CUCM at another site. We could have clusters of them at a single site to support even more IP phones. This is where we can set up our call restrictions. Voicemail, that can be done with Cisco Unity Connection, another server. For smaller offices, we might instead use a CUCME. That's where the communication manager function is inside the router, along with CUE, Cisco Unity Express, where we can have a module inside the router that gives us our voice messaging. And that might be good for an office size of up to maybe 500 users. But it's not just voice calls we want to be making over these unified communications networks. We also want to be able to send video. After all, these days we've got applications on our laptops, on our smart devices, where we can talk with one another using audio and video. We could use, Skype, for an example. Or we could use Cisco Jabber. Let's talk a bit about video on this next slide. Just some basic terms to know about video, and then we'll wrap up this preview discussion of collaboration. The first term I want you to know is frames per second. Now, this goes back to the movie theater, and when we're running the celluloid in front of that lamp and a projector, let's talk about frames per second. The lamp is going to show a certain number of images in a second, and if images are played in rapid succession, even though they're actually still images, it's kind of like one of those flip books. When you're flipping through it, it looks like there's actually motion going on. That's what's happening at the movie theater. We're watching different images projected in rapid succession. Now, of course, the projector doesn't just continually stream the celluloid film in front of the lamp, or it would be a big blur. So what the projector does, it shows an image, then there is a shutter that comes down to block the light, and the image is advanced. And then the shutter comes back up, and then we pause on that frame for a moment. And traditionally in the movie theater, we're watching at 24 frames per second. It kind of gives it that movie theater feel as opposed to our smart devices, which might do 30 frames a second or 60 frames a second. But back in the movie theater, let's think about that 24 frame per second rate. I'm not saying that we're going to show an image for 1/24th of a second. Shutter comes down, film advances, shutter opens, and we see the next image for 1/24th of a second. Having those interruptions every 1/24th of a second would start to become noticeable. We want to spread them out more evenly. So what was typically done in a movie theater was the film would advance, an image would be projected, the shutter would come down for 1/48th of a second. The shutter would open back up, and the same image would be projected for another 1/48th of a second. The shutter would come down, then the film would advance. You see what we're doing? There are two different times in which we're showing the same image. That makes the shutter come down 48 times in a second instead of 24 times in a second. That's going to make the motion seem a lot smoother on screen. That's called the refresh rate. So we might have a frame rate of 24 frames per second, but a refresh rate of 48. We see this on a lot of the 4K TVs out there these days. Instead of having a refresh rate of 60 hertz, it might be 120 hertz or 240 hertz. And again, that all goes back to the movie projector. And on some of our televisions, on some of our video displays, the older ones particularly, or the less expensive ones, we might see the use of interlaced video. With interlaced video, there's only so much bandwidth to project an image. So what we can do is have a high definition image that maybe has 1,080 rows, but we only project half of those rows during any refresh cycle. So let's say that we're on a television, we're sending 30 frames per second with a refresh rate of 60 hertz. What we would do in the first refresh rate interval is send half of those rows. Then during the next interval, where we're still sending the same image, we would send the other half of those rows to make a full image. That's called interlaced video. It's a way to take a limited amount of video bandwidth and give a high definition image. But that's not going to look as good as painting the entire frame during each refresh interval. If we can do that, that's called progressive video, where we send every row during each refresh cycle. And we often measure the quality of video in terms of pixels or picture elements. I took a picture of a couple of different music icons on a couple of Apple devices that I had. The one on the left is not the Retina display and the one on the right is. And you can see that the pixels are much more evident on the lower resolution display. And we also talk about aspect ratio when we're talking about video screens that we might have on a Cisco phone or a home television. Traditionally, the home TV would have an aspect ratio of 4:3, meaning that the length of the screen divided by the height of the screen, that was a 4:3 ratio. On higher definition TVs like 1080p TVs, we typically have 16:9 as our aspect ratio. And speaking of the 1080p TVs, what we're saying when we say 1080p, we're saying that it's 1,080 horizontal rows, and the P means that it's progressive video. That's opposed to 1080i, where we're sending half of the rows during each refresh rate cycle. And on a 1080p TV, we typically have 1,920 vertical columns. That gives us that 16:9 ratio, and it comes out to be a total of about 2 million pixels that are on that screen. Now today, 4K TVs are getting more popular than the 1080p TVs, and they have approximately 4,000 columns. They've got approximately 4 million pixels in a display. Now let's talk about some compression standards that are out there. I don't want to get too in-depth in this overview session, but there are some different ways that we can compress video or audio. One of the early standards was the MPEG-1 standard. You might think MPEG-1, that must be out of date. Actually, it's from MPEG-1 that we got our MP3 standard that we use for audio these days. There was an improvement called MPEG-2, and there was an improvement on that was called MPEG-4. And it's a variation of MPEG-4 that we use typically on our Cisco video networks to stream video. And it's H.264. is the compression standard that we often see used by things like our Cisco IP phones. And it's also what's used by Blu-ray players. That's another example. Well, that's a brief introduction to the world of collaboration, where we're sending voice and video and data, over the same network. And as I like to do in all of these, your Cisco Cert Success Path videos, I want to give you a discount on some further training. And if you're interested in going deeper with me in the world of collaboration, Cisco does have a CCNA and a CCNP in collaboration, and I've taught this and the predecessors to these courses, which were the CCNA and CCNP voice certs. I've taught those for years, dating back to like the early 2000s. And I've noticed that these different cert tracks, they talk about the same topics. Obviously, the NP goes more in depth, but they all talk about Cisco Unified Communications Manager. They talk about Cisco Unity Connection, Cisco Unity Express, the I'm in Present server. It's the same stuff, just at a deeper level. And one of the reasons that I think people fail their exams when they try to take a collaboration exam, for one thing, it's equipment. It's expensive to get a collaboration lab. It costs me about $10,000 to build this rack of equipment that I'm showing you on screen. Some people rely on books only. While I think books are super valuable, it doesn't give you the hands-on experience, and it's too expensive to get the hands-on experience, it would seem. So what is the solution? Well, I came up with a couple of video courses, one targeting NA collaboration and one targeting NP collaboration. And I use these video training courses not as a complete training course that tells you everything you need to know for the exams, but as a lab replacement. I go through plenty of theory, don't get me wrong, I go through plenty of theory, but we go through lab after lab after lab after lab where you can virtually look over my shoulder as I do the labs for you, so you don't necessarily have to have hands-on access. That's what I've done in those two courses. Now, the great news is Cisco has done us a huge favor. They've come out with the Cisco DevNet Sandbox, where we can get access to live gear. We can reserve it for a period of time, and we can use it for free, including some Cisco Unified Communications Manager gear. And I highly recommend that we get into that. And I created a short course covering 7 different labs on how to go out and for free use this gear that Cisco makes available to us. So if you want to go deeper in this, here's what I would recommend. I decided that since there is so much overlap and synergy between the NA and the NP collaboration tracks, I would incentivize people to take both. Now, you can go out to my website today and buy either the NA or the NP collaboration video series for $197 each. But to incentivize people to do both, because I think they really do complement one another, I took some of my CCNP voice videos that still completely apply to collaboration, where we look at how to set up just a whole bunch of features. It's like 20-some videos. And I threw those in, and I created a collaboration combo pack. Quality of service is super important when it comes to voice and video, and that seems to be one of the most challenging things for people to understand. So I took a QoS video series that I sold for $67, and I made that available in the pack. Now, if you were to buy those individually, it would be $558, but I said, you know what, if you'll get the combo pack, you just get everything, I'll just take a huge chunk of money off, and it'll only be $294 for everything. And I have sold many, many collaboration combo packs at that very reduced price. But as a thank you for watching your Cisco Cert Success Path, I want to give you another discount. I want to take that price of $294 and take away, no kidding, $200. So as your Cisco Cert Success Path price for being in this course, you get all that for $94. And as a bonus, remember that Cisco DevNet Sandbox Collaboration Labs product I had for $49? I'll throw that in for free. All you got to do is go to success-collab.kevin.live. Not .com, .live. It's success-collab.kevin.live. In fact, here's what you get. Here's a summary of the 5 different courses that you get. And you get all that, which is about a $600 value once you throw in the bonus. You get all that for $94. Success-collab.kevin.live. Leave that on the screen for just a second. You might want to pause it and jot that down. Now let's go ahead and wrap up this video. This video has been our 6th phase of our Cisco Cert Success Path. We laid the foundation. We went through all the different strategic technologies in order, and now we get to choose our own adventure. I'll see you back for the summary video next.